So you want to know how to get RF from point A to point B using these type of antennas. Well, my name is Mr. Mayor, and I'm going to try to keep it simple for you so you understand this. So come on, let's go. Welcome to the antenna block. We're going to be looking at antenna characteristics in Unit 1. This is a video series on Objective 1 Alpha. This is video 1. We're going to be looking at identify basic facts about the antenna theory throughout 1 Alpha. Just remember, you need to score 70% on your block test, which means there are 20 questions. You have to get 14 of those correct. Let's go on. First two we're going to look at is antenna theory and antenna waves. So let's look at the first one, antenna theory. We take a look at what an antenna is. It is a conductor and it radiates electromagnetic energy. Now on the other hand, it collects electromagnetic energy. Now I'm going to take you into my backyard and I want to show you what I have on my house. This is in my backyard. Now as you can see, I got a circle around the first one, which is at the very top of my antenna mast. We can pretty much look at what we classify these antennas as. Now please understand they are all, except for one, a receiving antenna. So the first one at the top is called a log periodic, or it resembles a log periodic. So let's take a look at the next one, or actually two. These are considered Yagi antennas, and we're going to get into that a little bit later on down the line. And then we have what's called a DV8 series antenna. Now the one I'm most proud of is this one right here. I made that antenna by going on YouTube and websites to figure out how I can make a transmitting antenna for my Christmas music. Now that sounds kind of strange, but if you take a look on YouTube, you will find a lot of homes that have their lights synchronized to music, and that's what I do. Let's continue on. So I've got a question for you, but before I ask that question, I have here a solid copper core 12 gauge wire that I took from an electrical stash. Now with this particular wire, it provides power to your electrical outlets. So when you take a look at the antenna definition, this is a electrical conductor. Yeah, it kind of fits that definition. We're going to take a look at this wire a little bit later on in the video series, so stand by. Antenna waves. These waves are pretty darn fast, like speed of light fast. They consist of an E field and an H field. These waves have three characteristics. They are frequency, wavelength, and amplitude. Let's take a look at each one of them. Frequency. That's how many cycles we can get into 1 second. We give it the term hertz for how many cycles we can get in that 1 second. So let's take a look at the red line first. We can see that we start here at 0, we go to 1 second. We have approximately about 0.75 hertz in this case. We go down to the blue line, we can go from 0 to 1 second. We have 1 complete cycle and almost over a half on the second cycle. So that's about 1.5 hertz. Let's look at the green one. We go from 0 to 1, and let's measure it. From here to here is 1. From here to here is 2. From here to here is 3, so it's a little over 3 hertz. Next up, we have wavelength. Now that is the distance between two consecutive points on a wave. So let's take a look at this. From here to here is 1 complete wavelength. From the crest, because that's what it's called, crest, and this, we're measuring from the top part of this to the other part, or the crest, and that's 1 wavelength. So let's look at the trough. Trough being down at the bottom. In this case, we can't measure 1 complete wavelength with
the bottom portion here. It's not shown in the picture. However, we can back it up just a little bit, and we can take this point and that point. That's one wavelength. And the last one is amplitude. This is a peak-to-peak measurement, and what we're going to do is we're going to compare it between the two lines that we have up here, the blue one and the red one. As you can see, the blue one isn't as tall as the red one. So you could say the blue one is a lower volume control than the red one is. So in this case, the red is like if you increase the volume control on your radio button and you're listening to a fantastic song and all of a sudden another song comes on that you don't really want to listen to. So there you go, you turn it down.
So I brought up an Air Force application so we can take a look at our wave characteristics using our senses. I'm going to only be using frequency and amplitude in this one, but as you can see, we do have an amplitude here, but we're also going to be using frequency. We're going to look at frequency first. So I'm going to lower the frequency, and you can hear the waveform go low. Adjust it for medium, and now we're going to adjust it for high. So listen at the different pitches that we have here. I'm going to bring it back down to the middle. Now let's vary the amplitude. Now, like I said before in the previous segment there, amplitude is nothing more than that volume control button. But I also want to take a look at this portion right here. Watch the amplitude go down. You barely hear it. Let's increase the amplitude. And you can see the waveform has increased in amplitude here. I'm going to bring it back down. We're going to go to the next one called EM characteristics, showing you the waveforms. So I brought up the other portion of the application. I'm going to go to electric field, and there's a reason why. We'll discuss that a little bit later in the course. And I'm going to pick vertical. Alright, horizontal to give us a better view. Notice again we have amplitude and frequency in here, but this particular waveform gives you an idea of what's traveling throughout space here. So I'm going to vary the amplitude. You're going to notice that when I go down, the wavelength gets smaller. When I go up in amplitude, it gets larger. So I'm going to bring it back down to the middle. I'm going to go frequency. Notice the wavelength. It's longer. Again, it's measured in cycles per second. I'm going to increase it midway. You can see that it's pretty much doubled, if not tripled. And then lastly, I'm going to go all the way up, and you can see this is a higher frequency. Kind of wild, ain't it?
Can we tell them now?
No, we're going to do a...
What?
We're going to do it next video.
Next video?
That's correct.
Oh,
next video.
I guess you're going to have to stay tuned.